force and motion and energy. So, remember, can anyone tell me what a force is?
Anybody?
Anyone? No one learned anything from our past experiments?
What about a type of force? Does anybody know a type of Miss Force? Or?
A push or a pull?
A push or a pull, yes. Ticket earned for you. Okay, so as our pre-assessment, we would have done a,
You have headers for each student, and so they can either work in groups or they can work by themselves. And so what they would do is put them on their desk, and they would have 12 different cards. And so there's different pictures. So there's one of pulling shoelaces. So you would look and say, oh, I would put that under pull. Here's somebody kicking a soccer ball, so that would be push. They're pushing. So you'd have 12 different pictures, and you would sort them until you were out, and then we, of course, would come around and check to see if you had gotten them correctly.
so that would be kind of like our pre-assessment. And our lesson is actually a post-assessment. So today you're going to design an experiment to test the effect of rolling marble, force on a rolling marble, and you are going to use the processes you've learned of a scientific experiment. Linda, yes. Would you please help me pass out materials? And a little background, Linda is my ADHD student.
Yes.
So I would have that student help me pass out materials to keep the student busy. So what you're going to do today is you are going to
Design your own experiment.
using marbles. You're going to have a cup, a ruler. You're going to work in your groups.
Yes.
So why is there four groups? I meant three.
It's okay.
I can do that. So you're going to work in your groups at your table. And as a group, you're going to design your experiment.
Yes. So we will.
We will share these at the end of class. Every group should have 10 marbles, a ruler, and a cup.
And again, we want you to play around and see what you can come up with.
So remember, the force of the push or pull is going to change the position of an object.
Yes.
So for example, if there was a door and I was pushing the door shut or opening it, the force would be my hand pushing the door, changing its position, or my hand opening the door, changing its position. That would be a force.
Yes.
Yes?
Yes. Does anybody know an example of a pull, since we gave you an example of a push? Pulling your chair out. Good job. Pulling the door.
Pulling your chair out. So
Good
the
job.
force would be her actually pulling it, so changing the position of the chair. So let's look at the first page. As a group, you're going to come up with your problem.
Yes.
Can someone give me an example of an if-then statement? Remember we did those for the experiment with the Hot Wheels? You remember?
Yes.
Guys, you don't need your science journals yet. We're gonna paste this in our science journals later. And I'll show you how I want you to do that. But on the first section, does everyone see where it says problem? Okay, as a group, you're gonna list 2 things that you could change about the motion of a rolling marble. Just 2 things, but of those 2, you're gonna just pick 1. What can you change about the motion of a rolling? And then,
Yes. That's what I was thinking. Yes.
yes, do you understand it? Before I was going to explain to you. Okay, yes, thank you. This group over here is on it. Good job.
So is Brenda's group.
Okay, does everyone have something for the first part? Okay, so for the second part, the question, you're going to come up with your question. And all you have to do, basically do is fill in that blank. And it reads, how can the blank of a rolling marble be changed? So depending on your problem, it's going to help you fill out that second part.
So think about it. Think about what you've learned. Think about what's been discussed.
Now this design is kind of set a little different. I would think that maybe you should take into consideration your materials that you're going to use. Because you don't have to use everything that's on the table. It just depends on your problem. Then you can move on to the hypothesis.
Does anybody know what a hypothesis is? Good job. An educated guess. Good job.
It's an educated guess. So based on your what? Can you make your prior knowledge and your problem or your,
Yes.
or what you're trying to find out, right?
Can you predict what's going to happen?
And so for a hypothesis, remember we did the if-then statement for the Hot Wheels? An example for this one, depending on your problem, would be if the, if the incline increased, then the speed of the marble or the Hot Wheel would decrease or increase. That's an if-then. Remember, we did that together when we did the last experiment?
Yes. Yeah.
Let's try it.
You're welcome.
Good job. Okay, you can move on to your materials since you know what your problem and your hypothesis is.
Think about what else you have on your desk that you can use.
next page, remember, in order to perform an experiment, you have a list of what? Directions, order, steps, and sequential order to tell us exactly how you're going to do this experiment. So now tell me exactly how are you going to do this? What are you going to use first? And then how much of something are you going to use? Like how many marbles? You each have 10 marbles. So, and the section that says details, tell me how many marbles are you going to use the first time? Or how many marbles are you going to use the second time?
It's better to have details than to leave us guessing.
Wow, that's good. So this is that's the change the incline. Maybe you had enough. Wait, what? Let's start from here and then.
What? Oh, okay, I don't know. Okay.
Different.
So now you have some smaller cups added.
Play with it. Don't be scared to try something out. You never know what you might end up finding.
Yeah, maybe 2 or 3 of you may each want to try 2 marbles and see if your results are the same or different. Remember, you're designing the experiment.
There's no right or wrong way if you're trying things out. That's what designing an experiment is all about.
And when you get ready to explain, make sure you understand what changed the force, what changed the direction.
What kind of incline did you have?
What was the friction?
Use things and build upon them. That's what we gave you materials for.
Remember that we need to build a smart
As you're finishing this up, on the second page, on the third page, I'm sorry, you are going to tell me how you're going to keep up with, take data or make a chart. How are you going to tell me the results of your experiment?
Does anybody know what data is? Do you know the definition of it? Good idea. Yeah, Ashley, go ahead and share it some more.
What we collect.
Good idea.
Yes. What you collect is based on your experiment.
I guess it should be at a slide, right?
And it can be it can be a chart, a table, graph.
Be creative. We want to see how you record your data. Use your vocabulary that we've taught.
Can someone tell me what would be your independent variable in your design, in your experimental design? The what? The marble. Good job.
Great job. What about defendant? Good job.
So once you have those steps listed, go on and try your design on your experiment. I want to see.
Yes.
You need to, no,